Okay, yeah, as Nick very appropriately introduced, I'm Varant. I am here today to talk about Zipline. A little bit more about me. I am a software engineer on the machine learning infrastructure team. Before that, I was kind of an engineer on the data infrastructure team and a data engineer at Airbnb. And during that time, I worked with a bunch of different teams to help build and deploy and launch their models. So a lot of the ideas that we had for ML infra came directly out of kind of the pain points that we had and the things that we saw kind of go wrong during that process. Before I move on, a fun fact about me. When I was really young, I got very sick on a flight from London to DC and made the plane land early in Canada. So that's my fun fact. On to business. So my agenda is to start with just a bit of context. I'm actually glad that I went third because I don't have a definition of feature store, so I'm glad that the first two talks did. I'll pretend like that was intentional, that I knew I was going third. But the context I'm going to set is just kind of around when a person would want to use Zipline, what sorts of projects would it help with, kind of roughly where it fits into the whole workflow. And then more specifically, exactly what the painful things are that Zipline addresses, and then kind of how we thought about the solution. Then if there's some time at the end, and I might just skip that part, we can go a bit deeper on some technicals. So context. I think one question, or when I've given talks about Zipline before, sometimes it clicks and sometimes it doesn't. And I find that often people have an idea of an ML project or an example ML project in their head. And depending on what idea that is, or rather kind of what three categories that falls into, this either clicks more or it clicks less. So this is a little bit experimental. This is the first time I've kind of presented this part of it. But the first thing that you might be trying to predict is something like image classification. You have this unstructured entity, and basically all the features, all the information about it is kind of encapsulated in that entity, right? So if you have an image and you're running a cat or dog model, your data's there. With every observation, every example, whatever you want to call it, the features are there, kind of all packaged up. I don't know if unstructured entity is actually the best title for that. But then the other thing that you have is another sort of entity prediction situation where for Airbnb, we might be, say, predicting a listing or classifying a listing as whether it's good for families or not. And the important distinction here is that we just have these entities and we're just kind of classifying them or making some predictions based off of them. And the important thing is that there's no inherent time component. There's nothing temporal about this. They're just listings, or they're just people, or they're just users. And we're just kind of running some prediction based off of them. This might be more clear once I contrast it with a third case, which is events, right? Now we have something like network traffic, and maybe you're a cybersecurity provider, and your model says, given these your model is based off of network traffic and classifying them as malicious or not. Now we have a situation where every single one of these observations or examples happened in the real world. It was an event, and it had a timestamp. And this kind of gets back to the conversation we were having just before in the last Q&A, where the gentleman in back asked that good question about backfilling, and we had a bit of back and forth about how important it is. This is the case where it gets very tricky, because now we have these events that happened, and it's very important to whatever feature values we assign to those observations for our machine learning, whatever training data we make, is as of that timestamp. And the next question, and again, I think this was talked about just a minute ago, is does your model run in batch only, or does it serve traffic in real time, right? This is kind of the other case which is relevant to whether Zipline is useful for you or not, or whether the service that provides these backfills of feature data is useful for you or not. And so kind of breaking it down in the graph, basically as we move from left to right, from my first one of kind of image classification to my last example of network activity, Zipline goes from kind of maybe not very useful at all, probably, to extremely useful, as in it's very hard to do ML without something that solves these problems for you. And then if you take my last question on top of this, which is basically are you trying to launch your model in real time? Are you trying to serve traffic, or are you just doing some batch prediction? If the answer is yes, we're trying to do online stuff, that goes from a lot to a lot. And the middle one might go from somewhat to very much so. So yeah, I just say this to kind of like set the scene that like most of the things that we talk about, or most of the problems that I'm going to talk about for Zipline are, in this third column, or fourth column rather. It's the events-driven ML. And on top of that, it's when we care about online serving of this model. And yeah, I think that this is a pretty common confusion when talking about like backfilling of features and so on and so forth. And yeah, actually that discussion that Nick and the audience had was pretty good about logging, right? A lot of companies, they just log their features. That way we kind of just like, guarantee that this is what we saw when we would have at this point in time, because we logged it at that point in time. But it brings up the issue of like backfilling new features. Okay, so motivation more specifically, what did we see at Airbnb? This was a very common sort of sentiment amongst data scientists. And we were talking about this just before, and I forgot who it was, but somebody said that 60%, that's not bad. We've seen that number go up to 80 or 90. So, and that's certainly true. So like you might have seen this comic about a bunch of data scientists slacking off while their model trains. But for us, it was more like, it's like my backfill is running, like I messed up my training data and I had to rerun it. It's like taking me forever. This was one big symptom of a lack of infrastructure that we wanted to address with Zipline. So let's look at why it's hard, right? Like why is feature engineering so hard for ML, right? Like, data processing and ETL frameworks are generally pretty good. Why is it lacking for machine learning? So let's say like for example, we're training a model that's when a user views an experience. So let me set some more context, I guess. At Airbnb, you can book listings, places to stay on your travel. You can also book things to do, which are experiences. So in this case, what we say is like when a user views this experience, so immediately we're onto the case of events, right? This is a model that runs upon page view. We want to make some prediction, as in we want to guess if this user has a high intent to book, because we might show some buttons bigger, something smaller, whatever. Purely hypothetical example. But let's say that's what we're doing. And so we might have an example feature here, the sum of prior bookings in the past 7 days. So now we have this timeline, right? And the prediction time is dictated by the product, right? The product says, I need to make predictions when a user views a listing. So this is the timestamp as of which my prediction happens. The label comes in later. It might come in hours later, it might come in weeks later. In this case, it would probably come in relatively soon if it's part of the same session, but it comes in the future. Then we have a bunch of feature values. So feature one in this case might be the example that I gave a minute ago. It might be the number of bookings that this user has made in the past 7 days. And these kind of change along a timeline. So what you want in your training data is your label plus all of the feature values as of that point in time exactly. And if you have another row, that other row has another point in time, right? So generating a feature value for a given point in time is pretty easy. It's pretty expressible in SQL. But when every single row, every single observation has a different timestamp, and you need these aggregations and these things expressed exactly as of those timestamps, that's when it becomes a very difficult data engineering problem. What a traditional data warehouse is good at doing for you is this, basically. Daily sums, right? Like right now with just simple Hive, SQL, Airflow, you can set up some jobs that say sum the bookings by user every day and write those daily partitions, right? But it can't give you those intraday values, not at least any technology that we've seen exist for traditional data warehousing or ETL. So then you might ask, like why is this so important? Does this really matter that much? Just take those day boundaries and like call it a day, right? Like just generate your training data and like, be done with it. And the answer is sometimes that might be okay, but a lot of times you get into some risky situations here. Let's say you go forward, right? And you take the end of day value. It's very easy to leak a label in this case, which means the thing that you're trying to predict, you accidentally slip that into your training data. Then when your model learns, it learns that this feature is great. I'll just like predict mostly based off of this feature, and it has a very high evaluation accuracy. But then when you go to production, the issue is in production, your data doesn't look that way. Your feature values look different. You can't leak the label in production because you can't go forward in time. And then your model doesn't do as well in production. Let's say you go back, right? Okay, now we've kind of solved that label leakage problem. We've gone to the prior day's midnight, and we're going to use those feature values. Well, the problem here is that you've lost some really good features maybe. Like let's say you're predicting something based off of user activity and you want to know the number of times they did something in the last 5 minutes, right? You're going to lose all of that basically if you throw away intraday accuracy. So this is why we cared a lot about intraday accuracy, and this kind of gets back to like that Q&A that we were just having. Like, does this matter? Why does it matter? These are the cases in which it matters, kind of. It's the cases where you're trying to do events-driven ML and you're trying to do online serving. It makes it very important to get this right. It's a complicated thing. I don't know. I've tried a lot of different ways of explaining this. I hope this kind of makes sense. I guess we'll see when we get to Q&A if this cleared things up or not. But that's a big part of the motivation was there. The other kind of half of the motivation, and this is another symptom we saw a lot, is like, and I kind of talked about this a bit. My model performs well, or at least I thought it did until I got to production. And so this kind of gets to the second. So the point in time correctness is one example of a broader thing, which is online-offline consistency. The data that you give your model at production time for scoring, inference, prediction, whatever you want to call it, has to look exactly the same as what you trained on. Otherwise, you get these funny situations where it looks great here, but it doesn't perform well when I need it to. A common cause of this at Airbnb was people basically training their models off of ETL, off of stuff that's in the warehouse. So you have all these like processed, cleaned up, good data tables that like data engineers and other teams have built. And people use that for ML because like why not? You're a data scientist, you have access to it. That's what you're used to accessing for data. And so you use it, right? And so you take something like user age and it's an integer and it's clean and it's been outliers have been removed and fake users have been removed, right? And you use that for training. But then when you go online, you're just like, oh, like how do I get this user thing from like the Hive warehouse? And what people do is like, oh, well, whatever. There's a prod DB field that has like more or less the same field, but there, instead of being an int, it's like some other timestamp thing, and like it throws off your model. I mean, that's a pretty contrived and like silly example. Hopefully that exact thing wouldn't happen. But the point is, as soon as you have ETL in your warehouse, it becomes hard, and you don't have access to that warehouse and production scoring. Like, how do you now guarantee feature consistency, right? One solution is logging, right? You can't log anything that you didn't have access to in the production logging environment, so you're guaranteed to have those features. But that brings in the issues that Nick was talking about a second ago, where you're depriving your data scientists of this huge warehouse of potential feature sources and processing clean data. So that's kind of like those were the main symptoms that we saw of a lack of a zipline at Airbnb. And like that's what we saw people struggling with, was like those two things, like hard to do my ETL and hard to debug my model looking good but not doing well in production. So that kind of gets down to like, now we move on to like the solution. So one way I like to describe Zipline is like, it's the time machine that you stick onto your data warehouse. So you stick Zipline on top of your data warehouse, and now you know these features that you were computing previously, Zipline can compute that for any given point in time. It can take your sum of user bookings in the past 7 days, and it can move that forward, it can move that back, it can backfill your data with point in time accuracy. The other thing that it does is you define your features once. Okay, so sometimes I like to call this Zipline travels through time and space. So you define your features once, and it can make them available in your data warehouse where you need access to training data, but it can also provide you feature values in the online feature store when it comes time to serve your model. So yeah, it's kind of like you define it once and it makes it available in the places you need it, and it can kind of move the value, the computation forward and back. I'm going to go into a little bit more specifics here when I kind of show you what it looks like. So this is kind of just like a mock-up of what we want our, and I haven't talked a lot about sharing and discovery, but one important piece of the feature repository is like you should be able to find features so that you can leverage other people's features. I think this was talked about much better by the previous talks probably than mine, but you should be able to kind of identify features and like do some visualizations and like understand at a glance what this feature is, what it looks like, does it fit into my model, so you can kind of leverage other people's work in an organization. But yeah, so that's a quick note on the sharing thing. But now I'm going to kind of jump back into what it looks like to define a feature and kind of how we actually enable that time travel to work. So here we have a simple feature definition. The source of this feature is a Hive query. So what this means is that it runs in batch, right? There's no streaming component. This is kind of like the simplest thing that a user can do. So in this case, they're selecting some fields from a data warehouse table. Now these fields don't immediately become the feature, but rather they're the raw data that feeds into the feature computation. So on top of defining the raw data, you define the operation that you're going to run and the time windows over which it runs. So now Zipline knows how to get your raw data, and it knows what aggregation you want to run, and it knows your time windows. The other key thing to note here is that it knows the primary key and the timestamp for each of these raw things, like these raw event rows that are going into your aggregation. As a result of Zipline being able to identify these things independently, I can now come to Zipline and say, hey, for user 123, for timestamp yesterday at noon, please give me the exact 7-day, 30-day, blah, blah, blah feature values for these features. So basically, we just give Zipline a little more information than we would a traditional ETL framework, where we might just give it a query that it runs every day with a group by and accounts, an account and a sum and an average function, UDFs. Because Zipline kind of can separate these things out, it now has a bit more control over how it generates data. That's kind of the key concept here. So this defines a feature. Like, what happens next? The answer is kind of, well, nothing, until somebody comes along and says, hey, Zipline, I need these features for these timestamps for these primary keys. So we're a little different here, I guess, than other frameworks that we've talked to, because some people, I guess at Branch, for example, you pre-compute a lot of things, which is something that we thought about too. I think there's pros and cons to either side, and I think you can make it work. But we do relatively little pre-computation of actual feature values until users come along and kind of make this request. So this is what the API looks like here. The first thing it is a list of features, which you can imagine is an important part of your training set. So here's the Python for saying, I would like these features from Zipline. But then the second thing that we ask for is this query that we call the driver query. This defines the primary keys and timestamps for which I want those features computed. So another way of phrasing this is the user gives us this, and Zipline fills in that, where that is some arbitrary set of features, if that makes sense. So the idea is what Zipline needs from you to make your training data is your primary keys, your timestamps, and the list of features. So you give it that, and it fills in all those values, and it guarantees you those features are correct as of those timestamps for those primary keys. OK, the other cool thing that we can do now that Zipline knows these things and knows your features is that in production, we have simplified the workflow of scoring a lot. So let's say we have a scoring request now for some model. And the model is the model I gave an example of prior, is the booking likelihood model. So before, if I was going to score the booking likelihood model, which I've already uploaded to my prediction service, which I'm not talking about today, but we have other information on that if you want, I would have had to get that whole feature vector myself and send that feature vector to the prediction service. This is where that opportunity for inconsistency comes in, is during that feature fetching. Instead now, all I do if I train my model on Zipline is I tell the prediction service, here's my primary keys, right? This is the user, this is the listing, or this is the experience, or whatever. And then what the prediction service can do is talk to Zipline, because it knows your model is a Zipline model. And it talks to Zipline and says, hey, here's my stuff. Here are my primary keys, and here's my Zipline source that was used to train my booking likelihood model. Zipline now makes your feature vector out of your primary keys. And if we think of the features as still being time traveled, the time here is always now. So the online feature stores never does a back in time thing, but it's always as up to date as possible. So it says, hey, here are your feature values as of now. And the prediction service says, great, now is indeed the timestamp as of which I'm scoring, because I'm the prediction service. And then it generates your probability and returns that back to the user. So we've taken away the need to kind of wrangle your online features, or wrangle your feature data at prediction time, which was really part of the main engineering overhead that we saw going into deploying a model. So in summary, Zipline is basically focused on time travel and consistency. There's some data quality and monitoring stuff, which I didn't talk about very much, but we have kind of built into our front end UI stuff, and we're still kind of working on that. Searchable and shareable, and integrated with the rest of the ML workflow. And that's about it. I don't know how I did on time, but I think we may have some time for some questions. Yeah, we got a few minutes? Yeah, okay. Yeah, questions. Oh, yeah.
You mentioned that what you need is primary keys and timestamps. What happens when, I have two questions. What happens when your primary key is a group versus just a value? For example, like if, for a user, I want to see all the users and how much they spent in the past 7 days on experiences. And the second question would be, what happens when the input to one of your features happens to be the output of a particular feature? Do you have any way of handling that?
Yeah. Can I answer in reverse order?
Sure.
No, we don't currently handle that, but it's a very interesting idea, and we've thought about it, and we kind of know what we would need to do to extend to support that, to like kind of pipeline features. It's a pretty interesting idea, and we've seen some people request it, so I might think about it some more. We just haven't prioritized it yet. On to your first one, I think maybe I explained things poorly, but that group thing is kind of, I think I often say like a primary key and a timestamp, but really it is kind of what you said. Like if you wanted all users, and you wanted their sum of bookings in the past 7 days, you would just write your driver query to select all users. The other thing that I might have overemphasized is one primary key. You can multi-key these things. So like for your user, for your device, you might have some count of views, and for your, so if you wanted like mobile and laptop, you could separate out those two. But yeah, it kind of is what you said. Like the group is the more standard thing. I just kind of gave the row by row example. Yeah.
Yeah. This question's related to the previous one about backfilling.
Yeah.
If you go back to the timeline slide,
Yeah.
you weren't using an example of backfilling there. You were just using that timeline slide to talk about consistency.
Yeah, so they're very related, I guess. So the reason why backfilling is hard is because it's hard to be consistent about backfilling. I guess is my point. So the point is when I backfill, okay, so if I was backfilling this training set for this model, and every online prediction corresponded to a listing view, right? My driver query in this case would be like select user listing TS from listing views table, right, for example. And then once I had that driver query, once I had those primary keys and timestamps, computing those feature values exactly as of those timestamps for each row, that's what's hard.
Right, so this gives you the ability to do that very easily.
Exactly.
Okay.
Yeah, that's exactly it. Yeah.
Okay, and second question, this is going to be an open source project, and would you, so why wouldn't the guys at Branch look at it or something like that? So tell me about the open source nature of what you do.
Yes, so we are trying to open source this. People always ask when, and I think it's pretty hard to estimate because, if we could all just sit back and focus on open sourcing it, we'd have it out pretty soon. But unfortunately, the company has demands of their employees, outside of what those employees want to do. But it's coming this year, exactly when, sooner rather than later, I think too. I think maybe like summer-ish would be a reasonable estimate. I just said that on camera, so I guess I'm going to be held to that. But yeah, we are trying to open source it pretty soon. As far as, I guess maybe Nick would be a better person to answer that, but I think that you took a lot of these concepts to your design at Branch, and maybe your implementation there were just more suited towards kind of what the demands were at the time. But I think we've talked a lot about our, compared, and there are some differences, but by and large, they solve kind of the same problems, I think, Zipline and Gondola, right?
Yeah, Gondola, Search of ours is like the larger, more stable version of the Zipline.
So, I think the answer is here. Nick saw it as a good opportunity to troll me, and that's primarily why they...
Yeah, ours is called Gondola. But, no, I've been asking him probably once a week when they're going to open source it. I think that there are a ton of pieces here that solve a lot of the problems that we had to solve. So.
And then there's Jim, who has already open sourced, right?
Yeah.
All right. Thank you.
Thanks.